Hi everyone. Hope you're doing well. Miss you so much. I know you've been excited for another math video, and lucky for you, this one is starring me. So here we go. Let's enjoy this wild ride. So last lesson that you did was the Pythagorean theorem, which is what we use to find the value of a missing side in a right triangle. So we're really going to focus on right triangles during this little mini chapter um, by now moving into what's called trigonometry. Trigonometry is really cool. It's something that you use more than you think you do, or something that can be applied in a lot of different ways. Trigonometry quite literally means the study of triangles. And that's what we're going to do, study these triangles. You use trigonometry if you ever play like 8 ball and you're trying to line up the cue with the ball that you want to hit because you're thinking about like the angle that you need to make and the distance that it's going. You're also using physics there, which is really cool. Shadows involve trigonometry. So we'll talk about more of that as we go. So there are 3 different trigonometric ratios that we're going to focus on in this mini unit. Each acute angle of a right triangle has the following trigonometric ratios that involves the sides of the triangle. So if we take a second and look at the triangle here, we notice that the angles A, B, and C are capital letters, and that the sides A, B, and C are lowercase letters, and that's intentional. That's going to be really important because this is case sensitive. When we talk about angles, we have to use the capital letters. Okay. So the first trigonometric ratio, trig function, if you will, is sine. And the abbreviation that you see on your calculator would be sin. So the ratio or fraction for that is the opposite side over the hypotenuse. So we're going to figure out what the sine of angle A is. So if we look at angle A right here, this is angle A. The sine of angle A, this is going to be opposite. This is always my hypotenuse because that's across in the right angle. So the sine of angle A would be side A over side C because that's my opposite side over my hypotenuse. Then, if I were to do that with, I don't know how to erase necessarily. Let's do this. We said that that was A over C. Now, if I were to do that with angle B is down here. Opposite, the side that's opposite of angle B is side B, and my hypotenuse is still side C because that's across from my right angle. So the sine of angle B is going to be side B over side C. All right. Then I want to do the cosine. Now we're looking at cosine. So if we look at angle A again, I want to find the cosine of angle A. Cosine is the adjacent over the hypotenuse. So if angle A is right here, this is my adjacent side because that means that it's touching it. So that's side B over my hypotenuse is still side C. That's always going to be my hypotenuse no matter what. We can do the same thing for cosine of angle B. So if angle B is right here, the adjacent side is the side that it's touching. So that's side A. And then this is also my hypotenuse for angle B because it's the same hypotenuse in the triangle. So the cosine of angle B is going to be side A over side C. Perhaps you notice something here or here. You can draw your own conclusion there, but you should be looking at that and asking yourself questions like, what do I notice? What do I wonder? Oh, I found an eraser. Good for me. All right, and then the last function is the tangent function. So that's the ratio of the opposite side to the angle to the adjacent side of the angle. So if we look at angle A again, angle A is here. The opposite side is here. The adjacent side is touching, and the hypotenuse is across from a right angle. So I want the opposite side over the adjacent side. So I'm not just going to write O over A, I'm going to use the sides that I need there. So that's going to be opposite over adjacent, so that should be side A over side B. And then when I do this for angle B, this is something that you can be predicting now. Or maybe pause and see if you can get the answer first before me. We can race. So the tangent of angle B, let me label my side. So this is the opposite, this is adjacent, and that is the hypotenuse. So I want the opposite side over the adjacent side. So in this case, that would be side B over side A. Nice. Cool, you just did your first trig ratios. How exciting. Sorry, I needed water. All right. Here we go. So there is a mnemonic that we can use to help us remember which side function is which. And it's called SOHCAHTOA. So spelled out, it's S-O-H. So, ka, toa. Maybe you look at that and you can figure out where that's coming from. But all that means is a way for you to just tell yourself which is which, because it's hard to remember all these ratios with these words. So means that sine is the opposite over the hypotenuse. Second writing, right? Cosine is the adjacent side over the hypotenuse. And TOA, tangent, is the opposite over the adjacent. So we're going to use that to help us with these different problems. So we did one of these before here with A, B, and C, but sometimes it's tricky when it's just letters. There's no numbers there. So we'll do this first example now. I give each trigonometric ratio as a fraction in simplest form. So this is important that we keep it as a fraction. We don't need a decimal equivalent here. And then simplest form, that's when we do math, enter, or we can do it on Desmos in another way. And I can show you how to do that in a little bit. So let's do all of angle A first. So angle A will be in red. So first I'm going to mark angle A right here. Here it is. So I'm going to label which side is which, whether it's opposite, adjacent, or the hypotenuse. So from the jump, I know that 13 is the hypotenuse. And there's two reasons why I know that. One of the reasons being because it's directly across from the right angle. The right angle is pointing to it. And then also because it's the largest side length. So I have all three side lengths, and 13 is the largest. So I know that that has to be the hypotenuse. Okay. Then angle A is opposite from that side over there. That side is BC. A is not included, so that's opposite from that. And then this side is adjacent to angle A because it's touching angle A. All right, so I'm going to use, let me scroll up. I'm going to use SOHCAHTOA to help me figure out the ratios here. So the sine of A. So sine is opposite over hypotenuse. Opposite over hypotenuse. So this should be 5/13. Try that again. 5/13. Nice. Cosine of angle A. So cosine is adjacent over hypotenuse. So for angle A, adjacent 12 over the hypotenuse 13. And then the tangent of angle A. SOHCAHTOA, tangent is the opposite over the adjacent. So the opposite is 5 over the adjacent is 12. 5/12. So I want you to think about what you notice and what you wonder. Just think about that for a second. Okay, so what I notice is that each number is used twice. 13 twice, 5 twice, and 12 twice. So it's a good way to know that I've used all of them. I wonder if these are always going to be fractions that are less than 1. Yeah, that's where I'm at. Maybe you can, in the post, just share some questions or things that you wonder. Wouldn't that be engaging? Okay, so let's do the same thing for angle C. Maybe you can jump ahead and check your answers, or maybe you want to do it with me. Let's make sure I didn't mess my stylus up. No stylus. All right, angle C. That's what we're working with. So I know that 13 is my hypotenuse. I know that 12 is opposite. And I know that 5 is adjacent. So sine of C. Sine. Opposite over hypotenuse. Opposite over hypotenuse. Cosine. Adjacent over hypotenuse. Adjacent over hypotenuse. Tangent. Opposite over adjacent. Opposite over adjacent. Nice. Again, I'm wondering what relationships we have here. I'm asking myself questions about that. I don't want to spoil anything, so I'm not going to give it away, but these are things that you should be asking. Okay. I have 2 more examples for you before you do your IXL practice. Here we go. So I want to do the same thing. Identify the sine, cosine, and tangent of angle W and angle X. Then I'm not going to do that for angle Y because that's a right angle, and there are special properties of the right angle that say we don't need to do sine, cosine, and tangent of that. So I have 1, 2. I'm missing the third side. So what that tells me is that I need to go to Desmos, or you can use your calculator app. I'll show you how to use Desmos. That might be helpful. And I wanted to, so it's 9 and 12. Okay, so I know that this is A, B, and C. So a little review, A squared plus B squared equals C squared. So 9 squared plus 16 squared equals C squared. 16. And then I can take this into here, 9 squared plus 16 squared. Did I make that up? I did. It's 12 squared. Oh, 12 squared. And that gives me 225. So 225 equals c squared. That doesn't make sense for this side length. There's no way that's 225. That's not logical. So I know I need to take the square root. So 225 is a perfect square, but if I didn't know that, I could press this calculator. And I think there's a perfect square. The square root, this is in my way. There it is. So square root of 225 is 15. That went away and I'll never be able to get it back. Okay. So that tells us c equals 15. So I'm going to put c equals 15 right here. All right, let's do angle W first. You label, and I'll catch up. Okay. So I label this as my opposite, my adjacent, and my hypotenuse. All right, so sine, I'm remembering that I have so, ka, toa. So sine is so that means I keep pointing with my stylus and not my mouse. Sine is so that sine is opposite over hypotenuse. So that'll be 12 over 15. We can reduce at the end. Cosine, ka, adjacent over hypotenuse. So 9 over 15. And tangent, toa, opposite over adjacent. 12 over 9. Alright, I'll show you how we can simplify those real quick. So 12 over 15, that divides and gives me a decimal. I don't want a decimal, or a reduced fraction, 4/5. Do the same thing with 9 over 15. Put it back to me as a fraction. And 12 over 9. And I'm just, again, pressing this button right here. 4/3. So we got ourselves 4/5. I'm sorry, I can't write that small. 4/5, 3/5, 4/5. 4/5, 3/5, 4/3. Nice, nice. We're getting it. Okay, I'm going to try to carefully erase this hot mess I created. Truly a hot mess. All right, and let's do the same thing for angle x now. So for angle x, this is still my hypotenuse. My adjacent side and my opposite side have now flipped. So sine, SOHCAHTOA. So opposite over hypotenuse, 9 over 15. Adjacent over hypotenuse, 12 over 15. And tan, TOA, opposite over adjacent. Opposite 9 over adjacent 12. I already reduced 9/15 here. That was 3/5. I already reduced 12/15 here. That was 4/5. And the tangent of x, 9/12. I didn't reduce, but I did 12/9. So this is just going to be the reciprocal, 3/4. Way to go, guys. Social isolation. Got me going crazy here. Okay. All right, last one. Then we're going to try quote together. Quote. All right. Remember, you can pause, replay, whatever. Do you? All right, last one. We also have a missing side here. So number here, don't have a number there. So I have to use old Pythagorean theorem. No, I don't want blue. I'm gonna freak out. It's gotta be black. A, B, C. So my Pythagorean theorem tells me a squared plus b squared equals c squared. I don't know what A is. I know what B is. And I know what C is. So in my calculator, I'm doing 16 squared, and I get 256. I do 34 squared, and get 1,156. And what do you do next? Yeah, you subtract 256 on both sides. So you're left with a squared equals 900. And you're thinking to yourself, well, I know the square root of 9 is 3. I know the square root of 100 is 10. So maybe it has something to do with that. It sure does. A equals 30. That's 3 times 10. Whole thing to go. All right. So it's old hat at this point. Let's do L first. The sine of L. Maybe give you a second to get set up. Do a little Sogatella situation on the top. I definitely suggest writing that out as you get used to the mnemonic. Even this is something that I continue to do because it's easy to just write the wrong number down because you did cosine instead of sine and you're only off by like one little part. You're still wrong, and IXL isn't going to like that. And then you're going to get mad. It's going to be a whole thing. So just take the extra step and write it down. So sine of L, I'm looking at L right here, and I'm labeling my hypotenuse across from the right angle, biggest side, opposite, adjacent. Looking at these big red letters there now. So the sine of L, sine, opposite over hypotenuse. So it looks like that would be 30 over 34. It doesn't look like a 30, huh? 30 over 34. Cosine of L, adjacent over hypotenuse, is 16 over 34. And then the tangent of L, TOA, opposite over adjacent, 30 over, that's 30 over 16. All of these are able to reduce, which you can do in your calculator on Desmos. I put a link in Google Classroom for the possible calculator emulators that you might need. So they're available for you there. So this would be 15/17 8/17, and 15/8. All right. Give you a second. You can pause this. Get yourself together for angle M. All right. Alright, so this is the same thing. It's the same SOHCAHTOA. Sorry, okay. Angle M, right there. Opposite. Adjacent. Hypotenuse. Sine. Opposite over hypotenuse. 16/34. We already reduced that before to 8/17. Cosine. Adjacent over hypotenuse. 30/34. Which reduces to 15/17. And then the tangent of angle M, opposite over adjacent, 16/30. And even though we didn't reduce that, we reduced its reciprocal. That's a 30, not a 36, just for clarity. So it's 8/15. Okay. So now you have the opportunity to do practice on IXL now. Algebra 1, please be mindful, it's Algebra 1. HH.1. So this is trig ratio, sine, cosine, and tangent. This will be linked in the Google Classroom assignment. If you have trouble logging into IXL, some of you have reached out already for your username and login. You're welcome to reach out and let us know if you have any questions. This will be uploaded, and you can just, watch as many times as you like. You can like and subscribe to my channel. No giveaways. Sorry. I don't know. Guys, I'm just trying to make jokes, but it doesn't work when I'm talking to myself. So it's going to be however long this is going to be for. But great job with this. We'll have another one for the second part of the week, and then the 2 tasks after this. No, we have 2 more lessons after this, and then the next 2 quote lessons are going to be activities. So if this is something that you get right away, that's awesome. If not, keep trying, keep practicing. Reach out to us if you need anything, and we can help you. Have a good day. Bye.